This is the first time we're here at the WDM conference. We've been focused more on packet side. So we're very encouraged to see this many people, and we're also very encouraged to see that people's ideas are evolving and people are looking at various alternatives to build networks. So that's certainly good for us. Yes, there's a fair amount of operators, certainly from growing markets. We've seen many people from Eastern Europe, Middle East, and Northern Africa. I think these are the type of people that are very interested on this topic. And then in addition, you know, there's still a fair amount of the more traditional operators as well. So I think overall it's a fairly good mix. Yes, the reason we built the converged supercore was to optimize core transport networks for the next couple of years of applications. Since everything's moving to packets, all new applications are IP-based, packet-based. Traditional applications are increasingly packet-based. We looked at an architecture to carry that, and as we have not really changed the core networks over the last 10 to 15 years, there is room for improvement. We've just stretched the architectures we had, so we thought that if we could do something new, what would be the ideal way to carry these applications, and that was to use MPLS as the center of convergence and complement that with optical transport. So it's an OTN transport providing you with the wavelengths and the transmission infrastructure over which you then layer an LSP switched network that becomes your primary carrier for your packet-based application. So look at it in this way, a label switched path is a circuit. It's just a packet circuit, and since everything's moving towards packets, we believe LSPs are the circuits of the future, so we build a switch that switches LSPs, and those are then carried over optical transport. So that's where that converged supercore idea comes from. The economic drivers are the fact that there's, let me say, three primary drivers. The first one is what we've been talking about for the last 10 years, that traffic is growing at near exponential rates. The second one is the increasing amount of unpredictability. In the sense of changing patterns. Mobility and cloud computing are causing things to move around in a network that used to be fixed. Customers move around much more, they're mobile. The abilities of the mobile radio networks are such that you can do things on the move that you could only do sitting in front of a PC 2 years ago. So that's bringing a lot of unpredictability in the network. Secondly, cloud computing will start content to move around. And when you move an application from one data center to another, you create a massive shift in traffic, and your patterns change, your aggregation becomes less efficient. So you'd have to start doing aggregation at a very fine level, which is almost a packet level. And then thirdly, maybe most important, is the fact that the amount of disintermediation continues to grow. So the fact that increasingly service providers need to carry traffic over the top, so traffic that does not belong to them, for which they do not see any revenue beyond the basic access service that they're selling. If you look at Netflix being 30% of internet traffic, if you look at BitTorrent, you look at basic HTTP services, you look at Facebook, you look at iPhone apps, you're looking at more than half of the traffic over the global internet, none of which carries revenue for the service provider. So at that point, your network becomes a cost center, and you have to do whatever you can to take the cost out of the network. And that's simplification, it's optimization, it's scalability, it's future-proofness. So all of these parameters were the drivers beyond, for us to create that supercore. Well, the alternatives we looked at and the alternatives that have been debated over the last couple of years are, the first one's basically to not do anything. It's just, the status quo where you say, well, I've done this the last 10 years, I was able to keep up with traffic, but The only thing you really do is stretch your architecture. You build bigger routers or switches, you install more of them, you create bigger wavelengths, you add more wavelengths. So ultimately you'd probably be able to keep pace, but at an enormous financial cost. And that goes against those other arguments where people are trying to take cost out of the network. Alternatively, some people advocate maybe less today than they did 2 years ago to just do circuit switching in the core. Because people have this impression circuits are cheaper than packets. But the challenge of doing that is with the increasing dynamics of traffic, you have to provision for worst case traffic, which means you have to over provision, which is expensive. And secondly, you make your edge more complicated. If all the routing decisions have to be made at the edge, you need a different type of device there. You need ports that do shaping, that do fine-grained queuing, which typically gives you less density, so you need more equipment. So you not only make it more expensive in the core, but you make it more expensive at the edge as well. And then the third architecture would be to try to bypass routers very aggressively, but now you're adding a layer of complexity in the network. You're adding that switching layer. You need to make sure that you can dynamically follow the traffic patterns, because bypass only works in a very static network. So lots of networks have bypass today, but it's a byproduct of optical network optimization. To pursue it as an aggressive strategy to reduce cost is very often disappointing. Oh, I would say definitely 100 gigabits. A lot of people are looking at it. I think some people are still struggling with where to use it. We've seen 100 gig being deployed primarily in the core of the network, primarily to relieve some congestion point in the networks, to take some link aggregation out of the networks. Another topic may be, should we do 40 gigabit or 100 gigabit? And there I think the debate will be more, 100 gig will certainly be telecom. 40 gig I think will initially be more data centers, for the simple reason that there are very few servers that have 100 gigabit interfaces. We only now see 40 gigabit interfaces come to market, so I think 40 gigabit will definitely be a driver in the data center. And then I think, maybe the whole discussion about OTN switching, MPLS-TP, I think the next 12 to 18 months, I think we'll see more clarity. We've seen a lot of evolution already in the thinking, say, compared to 2 years ago, where people are actually saying, well, I have a lot of MPLS in my network, I have a lot of DWDM and OTN transport in my network. Do I really need that layer in between that is circuit-based, for a packet world? So I think next year, maybe 2 years from now, we'll probably get an answer to that question.